Let's apply these same 8 steps to the next problem. F of x is equal to negative 2 times the quantity x minus 3 squared plus 8. In this case, my a is negative 2. My h is positive 3. It's the opposite of the inside of the parentheses. And my k is 8. It's not opposite. It's the same, exactly what your intuition would assume it would be. My vertex is hk, or in this case 3, 8. I could stop right here and plot the information that I already have. At 3, 8, I have a vertex. To find 2 more points, I can use my a. I can go right 1 and down 2, because my a is negative 2, and left 1 and down 2. We can also note that we have an axis of symmetry through my vertex. So I can actually do my axis of symmetry right now. X is equal to h, and my h value here is 3. To find my x-intercepts and my y-intercept, the x-intercept I'm setting f of x is equal to 0. For my y-intercept I'm finding f of 0. That's the difference about plugging in 0 for the y versus plugging in 0 for the x. So for the x-intercept I have 0 equals negative 2 x minus 3 squared plus 8. To solve, I subtract 8 from both sides. Next, I'm going to divide both sides by negative 2. Negative 8 divided by negative 2 is positive 4. I'm going to square root both sides. And whenever you square root both sides, you have to take the plus or minus part. So plus or minus 2 is equal to x minus 3. Lastly, I add 3 to both sides. And I have 3 plus or minus 2 equals x. Now, we never leave this value here, 3 plus or minus 2, because you actually know what 3 plus or minus 2 is. 3 plus 2 is 5, and 3 minus 2 is 1. So I have 2 x values where f of x is equal to 0. So my x-intercepts are 5, 0 and 1, 0. Next, I'd like to find the y-intercept. In order to find the y-intercept, I'm evaluating where x is equal to 0, or f of 0. 0 minus 3 is negative 3, and negative 3 squared is 9, which gives me negative 18 plus 8, or negative 10. So I can plot the x-intercepts and the y-intercepts on my graph. My x-intercept is at 5, 0, and at 1, 0. My y-intercept is at 0, negative 10. I can use my axis of symmetry to find one more point across from my y-intercept. My y-intercept is 3 units away from my axis of symmetry, so I'm going 3 units to the other side, and I have another point right there. I now have 7 good points on my parabola, and I can sketch. From here I can find the domain and the range. My domain is always going to be negative infinity to positive infinity. And my range, because my arrows are pointing downward, I know that I can go down forever. That's a negative infinity. Comma, how high can you go? Well, the highest value you can reach is at your vertex, which is 8. That high point is called your max. So we don't have a min, we have a max value, and we have a max value at 8, which is the high point of your range. Then it might ask you, where does this occur? And this occurs at x equals 3. So when x is equal to 3, we have a max value at 8, and the max value is always a y value. That will always be your k at x equals h. This is our last example that is already in standard form. My a is a half. My h is negative 1, the opposite of the inside. And there's no value out here. If it makes you feel better, you can think about it as a plus a 0, so my k is going to be 0. That gives me a vertex at -1, 0. Next, I'd like to plot -1, 0 on my graph. Using my a as positive a half, I can go right one and up a half, left one and up a half. In the previous problems, to find the x-intercept, we set f of x equal to 0. So 0 is equal to 1/2 x plus 1 quantity squared, and then I solved. Although, can anyone look at this picture and already tell me what my x-intercept is? Well, sure, my x-intercept is right here on the x-axis at -1, 0. Similarly, the y-intercept is already graphed on my y-axis here at 0, positive 1/2. I've already found the x and y-intercept just using my a, h, and k information from the function. Now, if you really wanted to set this equal to 0 and solve, you could. I'm going to multiply both sides by 2/1 to cancel out the 1/2, so I still have 0 equals x plus 1 squared. I take the square root of both sides, which gets me x plus 1 equals plus or minus 0. Although that's kind of silly, right? 0 is neither positive nor negative, so writing plus or minus 0 is just a little bit silly. So we have x is equal to -1 plus or minus 0, which really, when you add 0 and then you subtract 0, it's really the same thing, so we don't even have to write that. Do I still get the value at -1, 0? Sure I do. Although I'm hoping most of you could just look at the x-axis, see that you already have the x-intercept, and just be grateful that you don't have to do the work and you can just use the value. Similarly, I know we already know that the y-intercept is 0, 1/2, but let's say you forgot and you didn't happen to see it. You could evaluate f of 0, and in this case f of 0 is 1 squared is 1 times 1/2 is 1/2. So yeah, it still works. You can still use the previous methods, although I'm trying to save you a little bit of time if you happen to already see it. My axis of symmetry is always a vertical line at x equals h, and my h value here is -1. I can sketch that. You don't have to sketch it, I just find it a little helpful. You might get an extra point out of it. And now I'm going to sketch my graph. Notice this time I only have 3 good points. On the last problem I had 7 good points. The previous problem before that I had 5 good points. In this case I only have 3. I've only got what I got. So I'm just going to sketch the best I can and move on. My domain is always all reals. So that's almost kind of a silly question to ask on this section, but I need you to understand that all quadratics have all real numbers as their domain. Because my arrows are pointing upward, I have a low point. So the low point on my range is 0, and the high point goes up towards infinity. Because I have a low point, that gives me a min value of 0, which is the same value in your range. Where does that value occur? Well, at x equals -1. Again, that's always going to be the value k at x equals h, and that's what the min value or max value is, depending on if it's pointing up or down.